angles are those? Anybody share? They make a straight line, so they're linear, right? They're going to add up to 180 degrees, so they're supplementary. They're not congruent because they're not the same size. They're not vertical because they're not on opposite sides of an intersection, and they're not complementary because they add up to 180, not to 90 degrees. Okay, so you got to know those vocabulary words. Congruent, exactly the same. Vertical, opposite sides of an intersection. It looks like two V's coming together at a point. Linear pair makes a straight line. Supplementary adds up to 180, and complementary adds up to 90. Okay, if you don't know those 5 words, you need to write them down and make sure you know them. So now we go to question number 2, and I see right here it says A and B are complementary. If there is no picture, please draw one. I know complementary means 90 degrees. So A plus B has to equal 90 degrees. So I just add them up. 5x plus 22 plus 10x plus 8 equals 90. You got to combine your like terms. If you're not sure how to combine like terms, I know you guys were out a lot of Algebra 1, right? Because of COVID. So if we're not sure how to combine like terms, let's talk about that. But you got to talk to me. You got to ask questions. You got to tell me, I don't understand what you're doing. So I combine my 5x and my 10x to get 15x, and I combine my 22 and my 8 to get 30. Then I'm going to subtract 30 from both sides and get 15x equals 60. And then x equals 4 because I divide by 15. So x equals 4. But what's the question asking me? The measure of b. So I've got to put that 4 back into the x right there. So angle B is 10 times 4 plus 8, or 48. Okay? I'm basically giving you the answers here today because I want you to understand how to get the answers. I'm assuming that a lot of people, like half the class, didn't do the homework last night because you didn't know how to do it. It's not enough to know that the answer is 48. You've got to know that complementary means they add up to 90 degrees. You've got to know how to set up the equation. You've got to know how to solve the equation. Then you got to know how to substitute x. I know it's a lot. I promise you I know it's a lot. Okay, but I need you to ask questions if you're frustrated. So please unmute yourself if you have a question. Tell me to slow down if I'm going too fast. Oops, I just lost my screen. All right, so what's the relationship in number 3? What word can I use to describe those 2 angles? There's 2 main words. Vertical, absolutely. And all vertical angles are, starts with a C, ends in a T. Congruent. And congruent means they're exactly equal, right? So this equation, instead of being one angle plus another angle equals 90, this one, because they're congruent, they're exactly the same size. So 67 equals 2x plus 1. Here, I'm going to subtract 1 from both sides, and 2x equals 66. By the way, if I make some crazy algebra mistake, please call me out on it. I do make mistakes. So x equals 33. This is an easy question. There's no substitution. There's no craziness. We just get x equals 33. Questions? Okay. So what do I do for question number 4? What kind of angles are those? What words can I use to describe those? One of them starts with an L. Linear pair, perfect. And what do we know about linear pairs? Starts with an S. They are supplementary. And all supplementary angles add up to 180 degrees. So my equation here is the big angle, 5x plus 3, plus the small angle, 2x plus 2, equals 180 degrees. Because essentially that's half a circle. There's 180 on the right side and 180 degrees on the left side. So then we got to combine our like terms. 5x, 2x is 7x, 3 and 2 is 5. And then we want to get the x by itself. So we're going to subtract 5 on both sides. And then what's 175 divided by 7? Does anybody know what that is off the top of their head? Am I done, or do I need to substitute something there? Anybody? What's the question asking me for? Yeah, we're done because it's asking us for x. What about question 5? What words can we use there, or what can we eliminate? Because sometimes it's just as important to be able to eliminate things. I'm talking about A and B. What words can I eliminate, or what words do I need to keep? Somebody unmute themselves. I want to cross out linear pair because all we want is this part right here. If I said A, B, and C, then I could take the linear pair. So good. We want to eliminate linear pair. If we eliminate linear pair, and we know linear pairs make a straight line, which is 180 degrees, what other thing can we eliminate? Supplementary, absolutely. So now there's one that I know for sure I want to keep, and one that's kind of a maybe in my mind. So which one is the absolute certain? Complementary, because that right angle box is there, right? Do we know that they're congruent? Could they be congruent? It kind of looks like it's been bisected. It kind of looks like it should be 45 degrees and 45 degrees, right? If it said it was bisected, or if it had congruent marks here, then we could say they were congruent. If it is not marked, and it is not marked congruent right now, you cannot mark congruent. And that's the tempting wrong answer right there. All that is complementary, because that 90-degree box, that little 90-degree box right there, means that we can make it 90 degrees, which is complementary. Okay. Number 6 is kind of a nightmare of a question. I call these time-sucking questions. It's kind of a strange way to say it, but all the ordered pairs that would form a line segment with an endpoint of -1/8 that has a length of 5. So what we're asking here, and sometimes I have to draw it out on a little coordinate plane. I go -1 and then 1. Ooh, let me erase this because I made it too big. -1 and then 1, 2, 3, 4, 5, 6, 7, 8. I need a pen. 1, 2, 3, 4, 5, 6, 7, 8. Right? So that point there is -1, 8. And I want to know which of those other points have a length of 5. So if I plot those, and you can do this in Desmos, I think this is a great use of Desmos. So we go right 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. That's choice A. Is that going to be 5 units away, or can I eliminate that answer right now? So distance between -1/8, the yellow dot and the blue dot, going to be more than 5? Just visually? Yeah, I think so. right? So we can eliminate that one right off the bat. We don't have to do any work there. Then we go to B, let's get a different color, and we'll plot that. 1, 2, 1, 2, 3, 4. So now I've got 2, 4, and I know my drawing is pretty rudimentary. I don't need it to be perfect. This one is a little closer. This one might be 5. If I connected those, could the length be 5? I don't know. I can't eliminate that one. I eliminated A, but I get to keep B. So then if I go to C, 4, 8, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. That also might be 5, right? So now what do I have to do? What have we learned in this unit to figure out length or distance? The equation. And you could have started there if you wanted to. If I go to this first point and I use this one, we're going to make the face. Got eyeballs. What shape is my nose? Is it a plus or a minus? It goes in the middle. Minus. Plus goes in the middle of the eyes, and then minus goes like as the pupil of each eye. We got to make sure we square, right? So I'm going to put in my 2 and my 4. It doesn't matter where they go, 2 and 4. I'm going to put those second just because they're already on the right. And then I'm going to take -1 and 8. Oh, that's really hard to see. Let's find a different color. -1 and 8. And then we do the subtraction, right? So -1 minus 2 is -3. Make sure you put that in parentheses. And then 8 minus 4 is 4. Put that in parentheses just for safe measure. And then -3 squared is a +9 because a negative times a negative is a positive. And 16, and then the square root of 25, which equals 5. So my red point worked. So I got to keep that one, right? Then I've got that green point, and if I've done my work, right, all I have to do is erase that red point and stick that in. So let's see if that works. I'm going to take my green point now, 4 and 8, 4 and 8. -1 minus 4 is -5, and 8 minus 8 is 0. So these numbers change too. Am I going too fast? Am I making sense? 5 squared is 25, and 0 squared is 0. So the 4, 8 also works. In order to get credit, you need to choose both B and C and not A. Was that helpful at all to go through all of those? All of these kinds of questions are fair game on the test. You'll need to know complementary. You'll need to know distance formula. You'll need to know linear pairs and supplementary. You'll have to be able to substitute back in to find a length and know to leave it if it's just X. Can I have a thumbs up or a thumbs sideways or a thumbs down? Anybody?
Yeah, that was helpful.
Okay. Let's look at the homework. The homework was long, I know. Question number 1 looked good. I really don't want to go over all of these questions. I want to do 4, 7, 9, 11, and 12. So those are the ones I want to go over. If you started it and you have questions about it, let's talk about those. But question 1 looked good for the people who did it. Question 2 looked good for the people who did it. Question 3, shout out if I'm going too fast, if you want to talk about one of them. Question 3 looked good. Question 4, I think I know what the problem was here, but you stop me if I'm wrong, okay? So we've got LK, which is the small piece, and we've got 10, which is the big piece, and then X is the whole length. So this is the part plus the part equals the total. So 2x minus 22 plus 10 equals the total, which is x. We're to combine our like terms. 2x, that was a minus. Negative 22 and positive 10 is minus 12. How do I solve that equation? What's the first step when I have x's on both sides?
Move them to one side.
You got to move them to one side. Do I want to move the 1x to the left or the 2x to the right? And it doesn't really matter. We just need to choose. Okay. So if I move the 1x to the left, that becomes 0. A lot of people forget to put that placeholder of 0 there. Now I move my x's to the left. I need to move my numbers to the right. So I'm going to add 12 to both sides, and that's how I get x equals 12. So the first answer is x equals 12. But then I need to know LK. So where do I put that 12 back in? The variable, right? And I want LK, that's the short piece. So 2 times 12, and then minus 22. 2 times 12 is 24, and 24 minus 22 is 2. Okay. Questions on that? Sometimes it's this solving of this equation with just an x on one side that messes people up. 5 looked really good. So I know you guys know the concept. Say it again.
You go for 6 and 7.
I can, yep. Sketch a line that contains point W, Z, and T such that T is the midpoint of WZ. So here in geometry, we have a lot of problems that don't have illustrations. They want to know that you can create the illustration. If there's no illustration, I strongly, strongly encourage you to draw one. So we know here that W and Z are the endpoints, and we know that T is the midpoint. It's going to be so important for you to read those words. Then we know T is negative 2, 4. Let me change my color. Negative 2, 4, right? That's T. And then Z is negative 5, 3. So do I have 2 endpoints, or do I have an endpoint and a middle point? I think I have an end and a middle, right? So when you have an end and a middle, make that table. This is what we did on Tuesday. You want an end and a middle and an end. The middle point has to go in the middle of your table. So you do negative 2 and 4, and then the end point goes 5 and 3. And then how do I go from negative 5 to negative 2 on a number line? Am I getting bigger or smaller? Bigger. So I've got to add 3 to both sides, and you've got to establish a pattern and then follow the pattern. So negative 5 plus 3 is negative 2, and negative 2 plus 3 is positive 1. Then I got to come over here to my y's and do the same thing. How do I go from 3 to 4 on a number line? Add 1. So I add 1 more, and it goes to 5. That is my answer. 1, 5, or 1, 5. So whenever you're given a midpoint and an end point, you want to make a table, make sure the midpoint goes in the middle. It just kind of makes sense. It's in the name. And then find your pattern to go down the number line or up the number line. Does that help? Maybe a little bit, hopefully. Okay. I'm going to erase just the bottom part of this so we can see. Here, the question is kind of confusing. If I start at Kilbourne and I go to Dunford and then I go on to Eastdale, That's 2 legs of the trip. It's like I go from my house to my grandma's house and I pick her up, and then I go to my aunt's house for Thanksgiving dinner, right? We're making a 2-legged trip because somebody at Dunford needs you to pick them up in order to get everybody to Eastdale. So you've got to do 2 different distance formulas here. You've got to find the length here from Hilburn to Dunford, and then you've got to find the distance from Dunford to Eastdale. You can either do that with the ordered pairs and the distance formula, x minus x squared plus y minus y squared. Some people like that. We've already done an example with the distance formula, so I'd like to do an example with Pythagorean theorem. So let me see if I can draw these right triangles a little bit more clearly. If I start here and I go down and to the right, how tall is that triangle from Hilburn to Dunford? Somebody chatted 4. And then how wide is it? 5. And then the next triangle from Dunford to Eastdale, I'd have to travel, if I had to drive on the lines, I'd have to go right 2 and up 1, 2, 3, 4, 5, 6. All we've done is do this subtraction, but on the graph. Okay? I've literally just walked along the vertical and horizontal lines, but we're actually going to travel on the diagonal, and the diagonal always saves us some time. If you're trying to go across an empty lot, you're going to walk across the empty lot, not go around the sidewalks. So on this left triangle, we're going to do 4 squared plus 5 squared. Make sure you take the square root. We talked about that yesterday. And then 2 squared plus 6 squared. Make sure you take the square root. And then we're going to add those up. So the first radical, the 4 squared plus 5 squared, is going to be the distance from Hilburn to Dunford. That's our first leg of the trip. And then the second radical, the 2 squared plus 6 squared, is going to be the second radical. That's the second leg of the trip. And then you just put it in the calculator and solve. So 4 squared, 16 plus 25. So that's the square root of 41. And 2 squared is 4, 6 squared. So that's the square root of 4 plus 36, which is the square root of 40. And then you got to find those decimals, right? So that's just calculator work. Grab whatever calculator you use, whether it's Desmos or a handheld one or your phone, and then add them up. Round to the nearest, oh, I misspelled whole, the nearest whole number. Questions? Is that helpful? I need you guys to talk to me. Okay. I feel like I'm just giving you information. It needs to be two-sided. Question number 8. So if we want to use the Pythagorean theorem like we just did, and we know AR is 12, and we know that BD is 10, what do these little tick marks here mean? They're congruent. So we know BR is equal to RD, and the whole thing is 10. So which each of those little legs? Are they half? 5 and 5? So now if I draw AR, that's 12, and RD, that's 5. What's my Pythagorean theorem equation to get side C? 12 squared plus 5 squared equals D squared. So that's going to be this guy right here. So I want to look at 9, 11, and 12, and then we will be done reviewing for the day. How do I do 9? We got to find the coordinates. So the coordinates of A is what? -3, 1. And what's the coordinate for B? 3, -3. And how do I find the length? Don't be confused. Length is another word for distance. Do I want to find the midpoint, or do I want to do x plus x divided by 2, y plus y divided by 2, or do we want to do the face? So this one is going to be the distance, and this one is going to be the midpoint. Which one's going to work for length? The distance one. Yeah, so if we do the distance one, what number do I put in first? Okay, we can put in the -3. And then what comes next? +3. And then what? So I've got x and x. So I got to do y and y. 1, -3. And remember, when you put in a negative minus a negative is a positive. So then you solve it. What's -3 minus -3? -6. And then 1 plus 3 is 4. Let me erase the midpoint. So now what? So when I square it, do I get +36 or -36? Okay. And 4 squared is 16. So we've got the square root of 52, question mark? Sweet. Ten looked good. I don't know that we need to talk about 10. If this is the midpoint, then we know those two are equal, right? Question 7 looks a little weird. JB is the segment bisector of AD. So JB, that vertical line, is the knife that's slicing. So I know that AZ is congruent to ZD, right? AD is 24. That means the whole thing is 24. That's the total. And AZ, this left side, is 2x plus 4, and that's a part. Or in this case, because it's a bisector, it's really a half. So what equation can I set up here? There's several options. How are the 2x plus 4 and the 24 related? Are they equal? So if this whole thing, I say you have $24 and your little brother has half of that, do you have the same amount? So how would you relate the half and the total? So 2x plus 4 could equal half of this, right? Which would be 12. Or if I had both halves, because this half is 2x plus 4, I could do 2x plus 4 plus 2x plus 4 equals 12, or equals 24, my bad. So you got to be able to think about what's the whole thing and what are the parts, right? The parts together are going to be the whole thing. If I'm just talking about that little part AZ and ZD are equal. If the whole thing is 24, think of it like a string. It's a 24-inch string, and I've sliced it in half. When they separate, just like detachment and logic, those two pieces are both 12 inches. So I can take the left side, right, this side, and make it equal 12. Or I can take two of those, kind of glue them back together and make it equal to 24. And that would be this one. Half on the left plus half on the right equals the total. If you solve those equations, you are going to get the exact same thing. So if I solve the 2x plus 4 over here, I subtract 4 from both sides, and I get 2x equals 8 and x equals 4. Right? That's the easier equation to solve, I think. If I solve this equation, I get 4x plus 8 equals 24. And 4x equals 16. And x equals 4. So it doesn't matter if you do the part plus the part equals the total, a half plus the half equals the total, or the half equals the half. You just got to be able to identify what that picture means. Okay, and that is definitely what makes it difficult. I can give you a second to grab that information. Does anybody have any questions on that? Okay, I know it's a lot. I know it's a lot. And if you guys are getting super stressed out from geometry, I need you to tell me. Okay, that's not my goal. Can we do one more? We can go back up and do number 10. So what equation would you write here? If P is the midpoint, how are those two segments related? So I have this string ST. I know P is the midpoint, so I take some scissors and I slice it right in half. Now SP and PT are separated. Are they both half? Yeah. So if I know this is a half and I know this is a half, they should be equal. So we would do 8x plus 1 equals 7x plus 9. Which variable do you want to move and which number do you want to move? -1. That's what I would do. It's not the only way to do it. That is what I would do. So if I subtract the ones from the left, 9 minus 1 is 8. If I move my numbers to the right, I want to move my variables to the left. And you can do that all in one step, or you can do it in 2 steps, however you feel comfortable doing it. And then 8x minus 7x is x. So x equals 8. And then what's the final step? So we want SP, so we're going to take that 8 and we're going to stick it in right here. So 8 times 8 plus 1 equals 65, question mark? I love that you asked about that one. Let's look at the logic laws and remind ourselves about detachment. So I'm going to erase some of this. We've got 3 logic laws, and a lot of times, especially honor students, you guys think about what's true and what's not true, and you forget to follow the patterns. Sometimes more than the serious kids. So we've got detachment. Detachment means we always start with P, then Q. That's the way all of them are going to start. Detachment means I give you the beginning and you give me the end. Those are separate sentences. So the first sentence is a compound sentence. You've got a hypothesis and a conclusion. Then just like with the segments, we slice it in half. It's like you take the sentence and literally cut it. and you make a sentence out of the first part and a sentence out of the second part, and they both follow the same order. Is that what's happening here? If this is the P, that's the hypothesis, and this is the Q, and I encourage you to highlight your tests. Did the next sentence start with P? It started with Q. So this is not detachment. Detachment is valid, right? One of the other things that's valid is contrapositive. And when we do contrapositive, we've got to do two things. We've got to switch them and negate them, right? So we're still going to start with P, then Q. We're still going to start with that first compound sentence that has a period after it. But then we're going to take the end and bring it to the front. But we're also going to change it to a not. And we're going to take the P and take it to the back, but we've got to insert a not. This pattern is valid. Does this example follow that pattern? Does it say A and B are not complementary? It doesn't follow that pattern either. So then we've got a third valid pattern, and there are only 3 of them. There are only 3 patterns that can be valid, and that's the syllogism, right? That's like the story that you wrote me for the part 4 of the test. So syllogism, we still start with that P and Q. That compound sentence starts at the top, but then we have a third kind of clause, a third set of words, right? So the Q might repeat, but then we've got an R. You cross out the stuff that's double, and everything else just comes down, just like in algebra, to P and R. Here, the trick is we've got 3 compound sentences, right? If you don't have 3 compound sentences, it cannot be syllogism. This is our third valid pattern. If the question is asking you valid or not valid, it has to follow one of those 3 patterns. It has to keep the order and just detach the statements and put them together as 2 separate sentences, or it has to detach them, switch the order, change it to a negative, or you've got to have 3 separate compound sentences with something that repeats that you can slash out, and then everything comes down in the same order. Those are the only 3 valid patterns. Don't read the words for truth, right? On the last test, it was something like Michael is, or if you're 16, then you have a driver's license. If I have a driver's license, and then a lot of people just logically say, I must be 16, right? But that doesn't follow the pattern, because that's like this pattern. It started PQ, and then it gives you Q, so it's in the wrong order, but it's not negative. So guys, this one you have to choose not valid. Okay? Make sure you take note of these. If you're still not sure, those are the questions on the part 3 test that most people miss. Okay? Good and fair warning, take note of those. Detachment, separate the compound sentence, make 2 new sentences in the same order. Contrapositive, separate that sentence, flip it around and negate them and keep those 2 sentences separate. Or syllogism, you've got 3 separate compound sentences, something repeats that you can cross out, and everything else falls down in exactly its same place. Okay? I've been talking for a long time. I hate days when I'm talking this much, mostly because I know you're tired of hearing me. So I'm going to stop sharing my screen.